In this video, we're going to talk about graphs of functions. It's actually going to be a pretty short video. We're not actually going to do much theory. We're just really going to look at some examples. The only bit of theory we're going to look at is this vertical line test. This is a very simple graphical test for determining whether an equation represents a function or not. All you have to do is look at the graph of the equation and see if you can cross it anywhere more than once with a vertical line. If you can, it is not a function. The reasoning for this is actually pretty simple. Each x coordinate is an input, right? So if there are multiple outputs for an input, it's not a function. Well, multiple outputs would mean 2 points with the same x coordinate but different y coordinates, which would mean if you lay a vertical line on top of them, it would go through both points. So if there is no place where a vertical line can go through 2 points on your graph, it is a function. Let's look at some examples. I don't think we're actually going to start off with this. We're just going to examine the graph of a function and go from there. So let's see here. We're going to look at problem 11 here. So first, we have this lovely graph, which shows us the graph of function f, is this blue curve here, and it wants us to find f of 0 and f of negative 6. Well, this is finding function values graphically instead of algebraically. Last time in 3.1, we were given an explicit definition, an explicit formula for the function, and we would just plug in to find these. Now we've got the graph. Well, recall, this is the graph of f of x. So if I'm plugging in 0, that is an x value. So if you look at x equals 0 is right here, centered horizontally, I should say. Its y coordinate is 3, so f of 0 is 3. F of negative 6, well, you go over here, that's negative 3, 4, 5, 6. The point is down here. When you plug in negative 6 into the function, you get negative 3. And you can probably jump ahead if you want. F of 6. You go over here to positive 6. Here we go. X is 6, y is 0. F of 11. Right there. X is 11, y is 1. F of 3, positive or negative? So 3 is right here. That means this point is up here. Its y value would be positive because it's above the x-axis. Is f of negative 4 positive or negative? 1, 2, 3, 4. Here's negative 4. The point would be down here. So yeah, the y value would be negative. The function value would be negative. Absolutely. For what values of x is f of x equals 0? Notice in this problem, they're giving us y values because they said the f of x, which was our replacement for y, don't forget that, equals 0. So for what x values is y 0? Well, y is 0 along the x-axis, so that would be at negative 3, at 6, and at 10. For what values of x is f of x greater than 0? Well, some of them would say, well, it's here, 0, 1, 2, 3. No. This is a continuous line, so it has a point at, like, negative 1/2. It's right there. Negative 2.5. Negative 0.1 is up there. Now, this is going to be an interval. It's going to be a range of values. So let's actually write out this one instead of just doing it orally. For what values of x is f of x greater than 0? Well, it would be between negative 3 and positive 6. Negative 3, positive 6. Where else? From 10 to 11. It's an easy one to miss there. Although, let's be specific here. Negative 3 to 6, I cannot include either endpoint, because the y values are both equal 0. But 11, it's greater than. So I actually need to put a square bracket on 11. Because it ends not at 0, but at 1. What is the domain of f? Well, let's Domain, remember, is the set of inputs, which would be x values. The domain goes from -6 all the way over to +11. Domain is what? Negative, yeah, it includes -6, sure, and includes 11. What is the range? Well, that's the outputs, the y value. So it goes all the way down to -3, goes all the way up to 4. Doesn't skip any numbers in between. Goes over a couple of them several times. But certainly -3 inclusive up to +4. What are the x-intercepts? We've already found those in part E. -3, 0, 10, 0, and 6, 0. What are the y-intercepts? There is only one if it's a function. That would be here, 0, 3. So yeah. Oh, we're not done yet. I forgot. K, L, M, and N. How often does the line y equal 1/2? Y equal 1/2 would be right here. It would intersect, since it is lower than 1, it's at 1/2, it would intersect here, here, and here. Yes. So it would intersect 3 times. How often does the line x equal 5 intersect the graph? Well, that's a vertical line, so that would be here. But because it's a function, it can only hit once anyway. We know that, but once. It would be here. I'm in trouble doing a straight vertical line with my cursor, but yeah. For what values of x does f of x equal 3? Well, y equals 3 when x equals 4 or x equals 0. Right there. Those are where y is 3. What values of x does f of x equal -2? Well, -2 here, -5, and at 8. Let's move on to another problem. Or rather, a set of problems. In these problems, we are asked to determine whether they are functions, find the domain and range, find the intercepts, find any symmetry with respect to the x-axis, y-axis, or the origin. You may actually recognize these graphs from an earlier section. We talked about these specific graphs in 2.2, where we talked about their symmetry. Well, we're re-examining them now to see whether they are functions. Well, will they pass the vertical line test is the question. Well, if you look at 13, if you draw a vertical line here or here, you will hit the graph multiple times. Cannot be a function. We can still talk about the domain and range, really, although it doesn't ask us to. The domain would be -infinity to -1, union 1 to infinity, because those are all the x values it takes on. The range, it looks like it goes infinitely down and infinitely up and doesn't skip anything, so it'd be -infinity to infinity. 14 looks like wherever you draw a vertical line, you would only hit it once, so I would call this a function. Domain and range looks like it doesn't really ever stop going left or right, so -infinity to +infinity. The range, well, the y values, I don't know there. It looks like it might be just kind of leveling off at 0. If that's the case, if it never crosses 0, its range is 0 to infinity, not including 0. Range, RNG, would be 0 to infinity. Domain would be -infinity to infinity, because it certainly looks like it's going infinitely to the left and infinitely to the right. Symmetry. This has all the symmetries. This has none of the symmetries. It's not symmetric about the x-axis, or the y-axis, or the origin. Because remember, x-axis, if you rotate it around the x-axis, it would look like this. It would have to be the exact same graph. Well, it's not. It would be going down like this. If you rotate around the y-axis, it would be going up like this. Not the same graph. Not the exact same graph. So, not symmetric about the y-axis. Origin, you'd have to flip it both ways. So flip it down here and then flip it left to right. This means it would be going down here, which would not be symmetric either. It would not be the exact same graph, so it doesn't have that symmetry either. 15 would be a function. Its domain would be negative pi to positive pi. Its range would be negative 1 to positive 1. Oh, intercepts. Intercepts I didn't talk about, but you can read off the intercepts as well. You can see this has intercepts at negative pi over 2 and pi over 2. X-intercepts, Y-intercepts at 1. This is kind of neat. It is a function. Its domain would be 0 with a square bracket to 4 with a parenthesis, because it goes up to 4 but doesn't actually have a point there. It has an empty circle. The range would be from 0. Y is also 0 here, just like X is 0. Up to 3, but again, parentheses, because there's not actually a point there. Something really close to this 4 on the X, like 2.999999, but there's not a point at 3. And that's really the idea with 1.2 here. Pretty short section. Just talk about domain and range, intercepts, interpreting graphs. Let's see if there's anything in the applications worth looking at. Let's look at this one. This is a good thought exercise. So here we just have a bunch of graphs, and it asks us to match each of the graphs with the following functions. So we have this graph where it goes up fairly quickly and then levels off completely. Then we have this thing which just bounces up and down and up and down. We have this one which just goes up steadily. We have this one which is decreasing but increasing in speed of decrease. It's like falling and falling more rapidly as it goes. And this thing which is falling but leveling off. It's slowing down its decrease as it goes. So let's see. Cost of building a house is a function of its square footage. I would go straight to 3 for this, because the more you build, the more it's going to cost, the more square footage you have. So that's a pretty straight increase. The height of an egg dropped from a 300-foot building as a function of time. Well, as you drop something, it will increase its rate of speed, it will accelerate, and honestly, it would accelerate infinitely if there weren't wind resistance. Terminal velocity is only really a thing if you're in a medium that resists movement. If you drop something in a vacuum, it will consistently accelerate and accelerate and accelerate. So I would probably go with 4 for that. If you had a more accurate model, it might be a little something like this. It would honestly be close to this at the beginning, and then it would start leveling off after that. So I'm going to go with 4 would be height of a human as a function of time. Well, it's another thing that when you're young, you do pretty steadily increase your height as you get older, as time increases. But there's a maximum, and when you reach that maximum, you're not really going to go much farther than it. You might actually get shorter as you get older. So that's why we go with 1, because you increase to whatever your final height is, and then you stay there. That would be C. Demand for Big Macs as a function of price. So as price increases, we would expect demand to go down. For this, I think I would go with 5. Not only just because of elimination, but because as you increase price, you expect demand to go down sharply. But there's still going to be some demand for them. It's not necessarily going to go down to 0. I mean, maybe somebody who really likes hamburgers will still buy them, even as their price gets ridiculous. It'll level off at a new value. And that's why we go with 5. But that's really the only thing I would argue about, really, is between this one and the egg, whether these should be switched or not. Height of a child on a swing is a function of time. Well, that's just going to go up and down, because the swing is going to go up and down. So that's why we get this one. To see the child reaching its maximum height as they're either on the highest thing of their forward swing or the highest area of their backward swing. And then when they're straight down, you have this trough. This is definitely 2. And there's other ones that basically do the same thing. These problems are much like that, asking you to interpret what's happening on a graph. If you have any questions, just send me an email and we'll talk about them. So that's all of 3.2. 3.3 will be a little bit longer. We have a little bit more to talk about there. But I don't think it'll be that much longer of a video. See you then. Have a great day.